So this is David from FormLabs, and he's going to tell us a little bit about what they're up to.
Cool. Thank you very much for coming. And let me start with two quick thoughts that I had when I came here. One of them is Sean inspired me to think a little bit differently about the Form 2. So Form 2, the morphine of 3D printing. Sounds good? I think that's we never thought about it as aspirin, but also never as morphine. So the other one is we're here in Boston, and it's actually pretty unique to speak in Boston about 3D printing or anything engineering, manufacturing related. A lot of times you have to travel to San Francisco, New York, and other places. So as a community, let's try to change that. I don't really understand why there's all of this stuff is actually happening here, not anywhere else. So we are really happy to help out with that. So if anybody wants to do something together, please come talk to me after the talk. Let's organize something. All right, next 25 minutes. I want to talk about 3D printing and lasers, prototyping, random galvos, walruses and elephants. But let's talk a little bit about who's here. So who's an engineer? Okay, most of the people. Entrepreneurs? Okay, so relevant talks. How about designers? Okay. So, kind of similarly represented to how I think about myself. If I were a pie chart, I think I would look something like this. I'm originally a physicist. My accent is from Hungary. I'm an entrepreneur. I started a company actually here in Boston, and I'm a designer. Although nobody ever told me that I can call myself a designer, I still do that. It's mostly because I went to the media lab at MIT, where we kind of debunk these boundaries between engineering, design, and other disciplines. I worked on a bunch of random, rapid prototyping-ish things, a VR CAD software that I would still want to go back to it one day. And my company was this weird box sending service that I'm happy to talk about at another time, maybe. But let's talk about the Form 2. So the Form 2 is what I like to think is the most advanced desktop 3D printer ever created. I want to tell you a pretty personal story today about the Form 2. I led the development of the Form 2, and for that reason, it was basically occupying all of the 18 months between January of 2014 and sometime September of 2015. So if you ask me, these are kind of the most important questions. Why did we make it? We just heard a lot about starting a company, entrepreneurship. I think this is one of the most misunderstood questions. This is the most important question. If you start a company, the why do you make X is the most important thing that most people can't actually answer. A lot of times, especially in Boston, it starts with what can we make? Here's some technology that is really cool. Let's try to make it work. A lot of times it's more about what are the things that we can sell, and really the why did we make it is the most fundamental question behind entrepreneurship. How did we make it? This is what any maker, entrepreneur, engineer, this is the most fun part, the execution. How do you go from the concept to actually delivering something? And most importantly, if you're not terrible at it, then you should do it again. So you need to learn. I mean, we went through a couple of products before I think we got it just right. And so hopefully I can share some of those findings with you. But most importantly, I'm not sure everybody knows what the Form 2 is, so let me play this very quickly.
Selling SLA 3D printer and made it even better. Introducing the Form 2. Powered by a precision optical engine, the Form 2 creates laser-sharp prints with beautiful detail. With a larger build volume and smarter technology, the Form 2 is designed for performance. Now you can create perfect prototypes right on your desktop. We've redesigned the way we print. A new peel mechanism, A wiper and a heated resin tank work together so you can print parts not possible on other machines. An integrated resin system adds materials automatically. With wireless connectivity, sending prints to your machine is simple. The Form 2 is built for collaboration. You can monitor progress, receive notifications, or easily share your printer with your team. Engineered for precision, designed for reliability. The Form 2, the most advanced desktop 3D printer ever created.
I actually like the morphine tagline way better. So actually, this is a pretty good timing because last Thursday, it was the first year anniversary of the Form 2. So we've been on the market for exactly 1 year. So this is kind of the timeline of FormLabs, and these are all the different parts and mistakes that we've also made. Started on Kickstarter with the Form 1, and then about a year and a half to 2 years later, we launched the Form 1 Plus, which was kind of the updated version of the Form 1, and then finally the Form 2. But that's actually the printer. This is a widely misunderstood thing about 3D printing, that you're actually selling the parts, you're not selling the printer. The most important thing, the way I try to explain it to a lot of people, is that the Form 2 is 100 times better than the FDM machines that you can find on Amazon for $4.99, and 100 times cheaper than the industrial printers that you're kind of used to. But fundamentally, why did we make it? I like to go back to the way we think about the history of 3D printing. It's not yet very well written because it's still very much happening. But the way I look at it is, in the first 20 years of 3D printing, starting from the early 80s to when the patents started expiring in the mid-2000s, that's when, in rapid succession, all of the technologies were invented. You started from SLA, SLS, FDM, all of these technologies in rapid succession were invented and brought to market. But a lot of people were obviously not there yet. The first 20 years was bringing this technology and making it workable and reliable enough for people to actually buy it and use it. From the mid-2000s till about last year, that's what we call the hobbyist era. This is when a large number of 3D printing companies started distributing machines. What you saw is from couple thousands, couple 10,000 of printers worldwide, you went in a few years to a couple hundreds of thousands. Tons of machines, tons of new people involved in the ecosystem, but fundamentally, a lot of these machines fell short of one of the most important properties, which is reliability. When you buy a machine, any of you who are engineers or designers are using it in actual product development, the fundamental part that we're solving with rapid prototyping and 3D printing is everything is always late and everything is always over budget. And if you have a 3D printer that doesn't help you get to your deadlines fast and efficiently, you're actually making the problem worse. So when a lot of these printers, unfortunately, fell short of it. But we think this is the time with the Form 2 and with the 3D printers coming now, a lot of this is changing. Because fundamentally, the problem is still the same, that 3D printing is difficult, expensive, and slow. It's difficult because a lot of the machines end up needing a person to operate it. You need to train them, and they need to be an expert in order to use them. It's expensive, it's pretty self-explanatory, and the alternative, going to a service bureau, is usually slow. So when we're thinking about what are the goals for the Form 2, we started with these principles. Let's make a reliable 3D printer. This is where we thought a lot about the pill cycle, the heater, the wiper, all of the process changes. It needs to be easy to use. It needs to be something that you don't need to train somebody on. It's just something that works out of the box. And it needs to have the best parts that you've seen on the desktop so far. And we need to keep making it bigger, increase the number of materials available for it. The motivation coming from another angle is looking at how digital manufacturing at a greater scale. Today, there are kind of two big, if you look at how many parts are made per year, there's obviously the few parts, rapid prototyping, low volume manufacturing, and you start to go into mass manufacturing with consumer electronics, et cetera. we talk a lot about rapid manufacturing, which is kind of the in-between, the couple hundreds, couple thousands, maybe a couple 10,000s of parts per year. But when we were scoping out this machine, we were very focused on making a rapid prototyping machine. The slogan that we were trying to use is make the best 3D rapid prototyping professional desktop 3D printer ever. So this is hopefully the fun part. How did we make it? So how does a 3D printer look like when it's starting to get born? It looks something like this. A bunch of 8020s, kind of the Legos of engineering. This is the part where we're trying to figure out the process, the different parts of the machine, play around the different pill cycles. And you then start to think about these very mundane things, like how does a cartridge work? If you have ever come to FormLabs, you will see that a lot of our engineers are very young. This might be their first job ever. So when we looked around, who has designed the cartridge? The answer was nobody. So how do you start? Yeah, you take a bottle and you put a little pipe in it, and then that's pretty much a cartridge. Similar things to a wiper. But then you go a little bit further, and it starts to print. So that's actually Ian, our lead engineer, looking at the first ever print on a slide peel Form 2 engine. That caterpillar thing, I have no clue where that is coming from, but it's totally taken over. I think there are more of these caterpillar things being printed than rooks, which is kind of insane. We also print a lot of snails because our one of our engineers is obsessed with snails, so I think that's pretty much the only thing that he prints. But then this pretty fundamental moment happened where we kept on adding parts to the system, and we started to feel very uncomfortable with the complexity of the system. So this is a slide that we made internally for all of the engineers. This was probably like 5-6 months in, trying to show the difference in complexity between the Form 1 and Form 1 Plus and the Form 2 system, even at the place where we were at that point. The point of this was to probably do a little bit of introspection, probably a tiny bit of scaring about how just by adding a couple key features like the wiper, like the heater, like the cartridge, how much it exploded the engineering complexity and the number of parts, the number of subsystem, and how much integration work needs to be put in. So this is a very early block diagram of how complicated the machine was getting. Then, after you calm down everybody from inventing new features every 2 weeks, you get to something that starts to print. So this is the place where you don't even think about how things will look like or feel like. The UI is non-existent. It's mainly operated by one person from terminal. There's no user interface whatsoever. But it starts to print, and it starts to print reliably. This is where you start integrating all the components together, and the 15 prototyping boards start to condense into smaller pieces of actually manufacturable PCBs. And when you start making slides like this, that's probably a good time to remember that building your own Linux system is not always the right way to go. This is our electrical engineering team doing a very mature deep dive into their own souls about what are the different parts of building your own Linux system, how it can be retrofitted to a lot of other engineering problems, a lot of introspection, and then acceptance. I guess they copied the different parts of dying. But at the end of the day, our job is to reduce complexity for the customer. So once we got to a certain point of integration, we're starting to think about the user experience, and this kind of all came together on the UI. So this is a block diagram of all the UI states, and this is where we started thinking about not just how it prints, but how people will use it and how the interaction with the printer is going to go. And then the more fun parts of working on something physical, how should it look like? So on the right side, that's what became the final version of the Form 2. And on the left here, I don't completely understand why we were considering putting the cartridge right over the resin tank, but that was definitely something that we were thinking about a lot. But of course, moving in CAD is fast, but moving on paper is even faster. So I don't know how you like the Form 2 as a lava lamp, but it was at one point a really big inspiration. And we try to stay true to our customers. Like, our customers use this machine for rapid prototyping, so I think we're pretty good in rapid prototyping. We used actually the Form 1 Plus and other 3D printing solutions as well. You can see the resin tank on top, the wiper iterations, different machines. And these are all kind of helping us design actually a better 3D printer, because you get closer and closer to the way our customers are using it. We needed torture parts, and that means that we needed really, really big parts. And unfortunately, there are not a lot of parts that you want to print that are more than 200 milliliters. So I don't know who started it, but we started using dictators and busts of dictators. So that's Putin, Lenin, and Caesar, who were the first big prints on our machine. This is one of the things that I'm most proud of. We built our own Galvo system. So a little bit of background here. The reason why we can make our machine so efficiently, because we started doing very unorthodox things. One of them was the Galvo system. If you go out in the market and try to buy a pair of Galvos, you will quickly find that it's probably a couple $100. That's obviously not really in the range of prices that we can actually afford. So we went and bought Galvos that are actually used for laser light shows. That was the first Form 1 and Form 1 Plus machines that came off the line. They were all using these laser light show Galvos that were completely off in calibration and precision and accuracy. So when we were thinking about the first moments of the Form 2, we knew that the lasers and the Galvos are two key components that we need to do something about. And this is a completely insane thing to do. For a startup with a few tens of employees to try to manufacture their own Galvos, this is, as far as I know, never been done on this scale with this budget. And then finally things start to shape up. So this may look like just an average Form 2, but this is in fact the first Form 2 that ever looked like a Form 2. And definitely brought a lot of tears into a lot of engineers, because making one of the hardest parts after you get through the Galvo and laser system is making that large top cover. It's both Form 1, Form 1 Plus, Form 2 all have it in common. This is actually one-piece injection molded. It took a while to get it so beautiful. And once these machines were out there, we started carrying them around all over the world and starting to get the feedback that I think made this the best desktop 3D printer ever. So what did we learn? Good work takes a long time. So the stats are, it took 21 man-years to make it. We had less than 20 engineers who started working on it, and there were 40+ engineers when we got done. It was a total time of 22 months. Originally, we thought we were building a walrus with the gestation time of 1.4 years. Turned out that we were building an elephant, which is 2 years of gestation time. And the slightly embarrassing part is that while we were making this, we started running a meeting inside of FormLabs for engineers. And we basically asked a quick update from everybody. And at the end of every presentation, I presented the timeline, how much time is left. And it turns out that extremely consistently, I was off by 83%. So when I said that there is 100 days left, there was actually 183 days left. And surprisingly, almost over the entire course of the project, I was consistent, which I found extremely funny. Another thing, start testing early. One of the reasons why I think we've been shipping for a year, and it's been a very pleasurable year with more and more customers coming to us, is that we really didn't leave it up to chance. We started testing basically at the same time systems started to feel like they're going to be part of the final system. We did component testing and individual lifetime testing, environmental tests, put the poor machine into a dust chamber for up to 2 days and just kept it there, took it out, just took a quick pass at it. and then immediately started printing on it, and didn't stop fixing compatibility issues until we were able to print right out of it. But I think probably the most important one is that you need the best team. So I encourage you while you're here, if you're in Boston, please come up to me. Happy to give you a tour of FormLabs. We definitely are making these products well because we have the best team. And I think I probably need to finish pretty soon. So I'm just going to give you a couple of things that I'm really, really proud of that our customers have made in the last year. So this is the MIMO baby monitor. Who are using it both for rapid prototyping and manufacturing. They are a company that makes these little sensors that babies can, basically you can monitor your baby with a little variable. If you haven't seen the Shirley technique, please Google it. It's we have worked together with Indiana University to create a maxillofacial prosthetic for a cancer survivor, basically helping replace his complete jaw. We released biocompatible resin earlier this year. So actually there are real surgical guides being used all over in the field with FormLabs machines. And lastly, just because we are in a place where a lot of you know 3D printing and are in the industry, this is what I'm really, really proud of. We're both the top in manufacturer loyalty and most wanted printers. So I think I will stop here and happy to answer any questions.
Any questions? Come on, really?
What software did we design it on? We're mostly on SolidWorks, thinking every day about Onshape.